Welcome to Intro2Astro 2024.
Sure. So my name is Joshua Lieberman. I am a soon-to-be second-year PhD student at the University of Arizona, and my research is in extreme adaptive optics. So Maria is going to tell you more about adaptive optics a bit later in the course. And then also I work on direct imaging, which is one of the detection methods that we'll cover, where you're basically trying to take a picture of a planet and remove the starlight from your picture. Yeah, so I can share my screen now.
Yes,
yeah, so this.
Go ahead.
Oh, as they mentioned, this is an introduction to Matplotlib. So just briefly, what is Matplotlib? It's a plotting library for Python, but within all fields. So here are a few example plots. Is pretty straightforward. I think that participating in the AstroPy tutorials, then you probably already have it installed. And then as far as importing the plotting functionality, you will see a lot throughout your programming journey. Basically, here is the library Matplotlib, and then from that, we're going to import this plotting module. And then this last part is what's known as an alias. So you don't technically need to import pyplot as PLT, but it's standard convention in programming to do so. So now let's get into what this library looks like. So as I mentioned before, you can create many visualizations in Python with Matplotlib. So here we're importing pyplot and numpy, and we're also importing this. We're going to install and import this library called SciencePlot. And basically what these give you are what are called style files in Matplotlib, which is basically a file that outlines some formatting parameters. So because the default Matplotlib plots aren't super interesting or like publication ready on their own. So using these style files, you can basically format your plots however you would like. And you can also create your own. So getting into the actual plotting, let's say we want to plot the function y equals x squared. So we first need our data points. So here, as discussed in the previous lecture, we're going to use linspace to generate 5 numbers between 0 and 10. And this is going to be our x variable. And then for our y variable, it's going to be x squared. And so plotting this, we're basically going to see a line that isn't super smooth. And that's because we only have 5 data points. And also something worth noting, if you're using a Jupyter notebook, you don't need this plt.show, but it's often good practice to include it, because if you're using a Python script, this line is what will display the actual plot for you. So because I mentioned this line isn't super smooth, we can increase the number of data points. So when we do that, we have a much smoother curve, as you see here. But now we can change the plotting style a bit, customize a bit. So here we're specifying the color of the line, which is red. And then we're also using this argument, ls each, and ls means line style. So there are a few different options you can include for line style when you're customizing your plot. And these values are shown here. Additionally, you can see points along your line. And so we do that using this argument here, O dash dash. And you'll see that this tells us that we're we're plotting our points here, and then we also have a dashed line on top of that. And then we have these additional arguments, LW, which means line width, and then marker size, so where we set the size of our points on a plot. But there's also an equivalent syntax you can use, which might be easier to remember when starting out, where it's just the same arguments as above, but spelled out. So instead of using ls, you can also say line style, and separately you can define the marker and as well as the other parameters. In this way, it just kind of helps to self-document your code. And as you continue as a programmer and a researcher, you'll learn that documenting code is very important so that other people can follow along with what you're doing. So additionally, we can change the figure size for our plots. And we do that here with plt.figure, and then setting the figure size within this function. So when we have more than one plot, we also want to add a legend. So here we're plotting, we have our one x variable, our linspace, and then we have we're plotting two functions. So one of our functions will be for sine x, and then the other one will be for cosine x. So we can plot them on top of each other by calling plt.plot twice. And then just this syntax within the label. So this label allows you to create the legend. And then the syntax inside here with the $signs is LaTeX. And you'll learn more about that later in the course. It's basically for formatting equations and documents. And then here you can also specify your location of the legend, as well as your font size and columns within the legend. So as you can see, the position of your legend, there are multiple options you can choose from. And so it's good to be able to position the legend where you want so that it's not overlapping with the data that you want to show. So here's another example where we're plotting three functions on top of one another, cosine x squared, sine 6x, and then we're also plotting additional lines here. So you can also save your figure as a PDF as shown here. And so the plt.savefig is of course very useful for keeping track of your plots. But additionally, you can create scatter plots within Matplotlib. So to do that, we're going to use the function plt.scatter. So what you see here is that it's plotting just the data points with no line in between them. And again, we can create a legend for this data. Additionally, you can plot histograms in Matplotlib. And so here what we're doing is we're generating a sample of 1,000 values from a normal distribution with a mean of 0.4 and a standard deviation of 0.2. And what that looks like here is we define our figure, and then we use the function plt.hist. And you'll notice there's this additional argument called bins. And that basically tells you like how you want to kind of separate your data. So you see here, when I don't specify bins, we have these larger kind of blocks, whereas you can increase the density or like the resolution of your plot by increasing the number of bins. Additionally, we can choose to draw only the boundary as shown here. And another really powerful feature of Matplotlib is the ability to create subfigures. So this is what you'll be using pretty often as you progress as a researcher. And that's because this method allows you to create multiple diagrams in the same window. And it's very versatile when you want to customize your plots. So here, where this function, we have two variables from this function. Figure is like the canvas. So the basically controls the size of our overall figure. And then axes has to do with kind of everything that we're plotting. And so you can see that laid out here. And then the other thing worth noting is this is also a really good argument to include in your code, tight layout. And it basically reduces extra white space from your figure, which is very helpful when you're saving out your figures. So additionally, you can create error bars in your plots. And so you do that using plt.errorbar, and you include your x and y arguments. And then you also specify the amount of error using this y error parameter. And so here it shows various methods in which you can do that, where you can create both upper and lower limits for your error, or just plot one or the other. So additionally, of course, Matplotlib is very applicable within astronomy. So here we're going to open up a FITS file, which contains a spectrum. So you can see here that here we're plotting wavelength against flux, and you can overplot horizontal line or vertical lines on your plot using Matplotlib. And this is very useful for examining a specific wavelength in your spectrum. But additionally, we can also plot HR diagrams. So here we're calling in data from the Gaia database, which is a satellite which contains, which gives us a lot of really useful data on stars. So what that looks like here, here you can see our two HR diagrams, and we're using this hexbin argument, which is particularly useful when you have a lot of data, because it just, it basically makes your plots look a lot neater. Additionally, we can use FITS files. We can open up images and look at those as well. And so this is what I do quite often in my research. And so you do that using plt.imshow. And here where I'm adding in this extra argument origin equals lower, which I do all the time when plotting images. And it's because when you specify this argument, it'll set the y-axis to start at 0. Otherwise, your image will appear flipped. So you can see here, we've changed the color map, and we've also included a color bar. So below also are some exercises, basically, that you'll be doing for your assignments. And then additionally, we have more resources at the bottom. And I just want to take a minute to briefly go over some of these resources, because it can be, sometimes it can be very overwhelming to be presented with a whole PDF, like the whole book basically on programming. And it can be hard to know where to start. But within research, learning how to look up documentation to find the specific code that you want is a skill in and of itself, similar to learning how to read papers. So how I often utilize these resources is when I'm trying to figure out how to use a new function, say in Matplotlib, is I'll do it kind of on an as needed basis. So let's say, for example, I want to create another image within this one that appears zoomed in. So I might go to this link here, and I can just search zoom, and then I found the code that I want, which will basically help me to execute this plot. So this might seem straightforward, but it's a very useful skill, basically, as you continue to progress in your journey as a researcher, to basically call upon these resources as needed. So yeah, that's everything.
All right, thank you so much, Joshua. It was very informative. Yeah. I learned something new too. All right, maybe this is a good point to pause for questions.
Sure.
You raise your hand if you have a question, or you can simply type in the chat.
Yes. So yeah, you're correct in noticing that I used SQL here. So basically, there are multiple methods of querying data, and this is one way you can get data from this database. And SQL stands for Signal Querying Language. So this is another programming language, and basically what it's saying within this command is we're selecting multiple variables from this database, and then we're including this parameter where parallax is greater than 50. So for Gaia, it's helpful to use this kind of syntax because of just how much data the Gaia database contains. And so this allows you to basically acquire your data more easily than just trying to search, say, using a search bar. Yeah, I don't know if that helps.
Yeah,
But
SQL
yeah.
is now covered in the course. It's a bit more advanced for what, but there are plenty of information online if you want to learn about it. All right, any other questions?
Oh, is that? Oh, sorry, what was that question that's just posted in the chat?
Yeah, how do you know of the right parameters to select when selecting data?
Well, that will depend on your research case, I think. So I don't know if you have more to add to
Yeah,
that.
I think what Equity meant is how do you know the column name? I guess this is by reading the documentation of the data release. Usually the science team, they will decide on a standardized name for the various parameter. That's what you see in cell 32. So you have to look this up in advance.
Register now on bit.ly/Intro2Astro 2024.